Geotechnical engineers are always facing situations they've never seen before. We're dealing with materials we've never come across before, and possibly nobody has really thought about them. Well, because I'm a geotechnical engineer, the most important elements are to understand what's down there in the ground. And that's always a matter of probing, of trying to guess what's there, of trying to understand what other people have discovered in the locality. It's a very observational business. You can't do it just by logic or pure science. The key project probably for me was the British Library, because that was a sort of turning point in our understanding of the behaviour of the ground and my own development of my thinking. The British Library was, I think, the biggest excavation in London, possibly the biggest there's been almost, even now. Very deep, very large in area, because it's there to store hundreds of years of books. So it has to be extremely secure, extremely watertight, and we were designing to very tight criteria of movement. We couldn't damage the adjacent St Pancras station, for example. And I think it was really in that project that we began to push back a few scientific barriers in our understanding of the behaviour of the ground. We particularly realised the great importance of the way its stiffness, its whole behaviour changes as it starts to deform. And that was new at that time. It hadn't really been understood up to that point. I was employed as a special advisor to a parliamentary committee, the committee that looks after the parliamentary buildings, which is the Houses of Parliament, including the clock tower, but also the other buildings around us here. The Jubilee Line's a major connection. It intersected with existing lines that go through Westminster. And in the course of that construction, there was concern that it would damage existing surface buildings. It passed pretty close to Big Ben, and there was concern that Big Ben would start to move and tilt a little due to that construction. In fact, it did. It did. Most of those buildings moved a bit, cracked a bit, and the designs had to be carefully prepared so that cracking wouldn't be too severe. It was monitored very carefully. We were receiving reports of the amount of movement, and as it started to lean towards the excavations that were being made, particularly the tunnelling, it was pushed upright again by pumping grout beneath it. So it would lean a bit, it would be pumped back, it would lean a bit, it would be pumped back, and that process went on for the best part of a year, I think. The monitoring is still continuing, so that we know how much it moves as it gradually continues its historic tendency to lean a little to the north. I think somebody who's coming into this field of engineering needs to start from a very strong grasp of physical understanding of the world around them. So that comes from education, but it perhaps also comes from their natural inclinations, and without that they're going to struggle. I think by nature I'm just fascinated by the physical universe. You look down into a piece of dirt, you see the way it behaves, the way the particles interact with each other, and there's another level of fascination. It's just like the stars and the planets and so on. So that there's whatever level we look at nature in, we find a fascinating world to study. That, for me, is a great fascination. And then part of the motivation is also to do something that contributes to society, to our clients, but more generally also to society in large. When we had I think it was our 60th anniversary, the firm made a commitment to start to support the charity water aid in a fairly significant way. So we now have engineers who work with water aid, who go out on secondment to them for certain periods. We raise money in various different ways, because we see that particularly with the advent of climate change, the provision of water and of sewerage and all the things that go with water, the provision of those things to poor communities is absolutely vital. And I think it's now running strongly through the ethos of Arup to be heavily involved in that sort of work. The creation of the Arup Fellowship really is a demonstration of Arup's commitment to technical excellence and to the fact that it's not only business management that is important. It's not only being able to turn in very profitable projects, but also having a real understanding of the physical world, because that actually is what we sell. That's the basis of our design work. So it's important that Arup is committed to that. And for me, probably the biggest significance of being a fellow is its effect on my younger colleagues, because they can see that Arup prizes technical ability, technical excellence. And it's important that they understand that and have something to aim at.